This is problem 35 of chapter 16 from the textbook Stats Modeling the World, 2nd edition. So this problem is called more cereal. It's very similar to the problem 33. It takes a lot of data from 33, but the box this time has a different amount in it. So let's see if we can do this. So I think what we're told is the box. Let's see if I can draw my cereal box. Here it is. It has an expected amount of 16.2 ounces. I don't know why I did that. That's silly. Let's use B for box. Is 16.2, and the standard deviation of the box is 0.1. Okay, so now remember for the large bowl from 33, the expected amount of the large bowl was 2.5, and the standard deviation of the large bowl was was it 0.4? So 0.4, and the expected value for the small bowl was 1.5 with a standard deviation of, I believe it was 0.3. Okay, so finding, let's see, suppose the amount of cereal in the manufacturer puts the boxes is random, blah blah blah. Okay, so we're pouring a large and a small bowl. So here's our large bowl, I guess, and here's our small bowl. So we're going to pour some out, and we're going to pour some more out. So it's going to go down. So the question is, how much is left in the box? Find the expected amount. Well, that's pretty straightforward. That's the expected value of the box minus the large bowl minus the small bowl. So that's just the expected value of B minus the expected value of L less the expected value of S. So just plug and play. So 16.2 minus 2.5 minus 1.5 gives us an expected value of 12.2 ounces. Okay, so now we want to find the standard deviation. So this is kind of a repeat. That's not what we need. We need the variance. Let's start with the variance. So the variance of the box less the large bowl less what's in the small bowl, what gets poured in, is the variance of the box plus, this is the key right here, plus the variance of the large, because the variability adds to the variance of the small. Okay, so this is just going to be, remember that the variance of anything, the variance of x, let's just say, is the standard deviation of x squared. Okay, another way of saying that is that the variance squared, the variance is the standard deviation squared. Okay, so let's just plug and play here. So that's going to be 0.1 squared plus 0.4 squared plus 0.3 squared. So that's going to be 0.01 plus 0.16 plus 0.09, and that's going to equal 0.26. So the standard deviation is going to be the square root of 0.226, and that should equal 0.51 ounces. Let's just check real quick. Pull up my calculator. So 0.26 square root, yeah, 0.51 if we round, okay? So that's the standard deviation. Now, if the weight of the remaining cereal can be described by a normal model, in other words, if we can do this, I didn't like the start of that. Let's try again. Good enough. Okay, so the center is 12.2, right? That's what we calculated here. 12.2, and a standard deviation of 0.51. So I'm just going to use this notation here, 12.2 and 0.51 is the standard deviation. So if we can assume that the variable here is actually B minus L minus S, that's this difference. Okay, so what's the probability that the box still contains more than 13 ounces? So I don't know where 13 would be. Let's see, 0.2 plus 0.5, that's about 12.7. So I bet it's about right in here. I bet 13 would be right there. Okay, so what we would like to know is what's the z value. So let's back up. What they're asking us is, what's the probability that B minus L minus S is contains more than, so greater than 13 ounces? Okay, so that's equal to the probability that Z is greater than 13, subtract off the mean of the model, divided by the standard deviation. Okay, and that's going to be the probability that Z is greater than 1.57. Okay, so then we can use the calculator, normal CDF, and so this is 1.57. So 1.5 standard deviations, or almost 1.6 standard deviations away from the mean. So we want to find this area. So we're going to go from 1.57 out to infinity, which we're going to approximate with a positive 999. So we're approximating infinity. Okay, and so that gives us 0.058, or if you want to use percent, that would be 5.8% of the area under the curve. So according to the normal model, the probability that the box contains more than 13 ounces is about 0.058 or 5.8%. Okay, so writing out the answer is pretty important if you want full credit on the AP test. Okay, so that's how you do this problem. So good luck.